Let's jump right into this explainer. Today, we're unpacking an absolutely massive, globally distributed journey. We are going to trace the entire life cycle of smartphone manufacturing, literally from raw earth extracted out of the ground, all the way to that finished supercomputer sitting in the palm of your hand right now.
But before we get into the actual nuts and bolts, just pause for a second and ask yourself, what does it genuinely take to build the supercomputer in your pocket? Research shows that the average person touches their smartphone something like 2,617 times a day. I mean, it's a total constant in our modern lives, right? Yet we rarely, if ever, stop to think about the sheer manufacturing miracles hidden behind that smooth glass. It is a literal triumph of engineering and global logistics. To even begin to wrap your head around the scale we're talking about, just look at this number, 1.15 trillion. In the year 2021 alone, 1.15 trillion semiconductors were shipped worldwide. If you break that down, it's roughly 145 microchips for every single person on Earth. And, no surprise, a massive chunk of those chips are going straight into the smartphones we rely on daily.
Okay, so here's our roadmap. We'll quickly hit concept and raw materials, move right through component manufacturing and the assembly line, take a look at software and quality control, cover packaging and global distribution, and finally weigh the life cycle and environmental impact.
Let's kick things off with Phase 1, concept and raw materials.
Making your phone actually starts years in advance. Long before a physical device even exists, engineers are plotting out hardware compatibility, which then triggers this massive global extraction effort. And I mean massive. Believe it or not, a single smartphone contains roughly 80% of the stable elements on the periodic table. For example, your touchscreen uses indium to register the electrical charge from your finger. The electronics need nickel, gallium, and tantalum. Your battery relies on lithium and cobalt. And those tiny speakers and vibration motors, they absolutely depend on neodymium, terbium, and dysprosium. So yeah, it's a global harvest packed into one tiny device.
Which brings us to Phase 2. Manufacturing the core components.
Before these raw materials can ever hit a final assembly line, they have to be transformed into the core components. And the undisputed king of complexity here is the microchip. Companies like ASML use 6 totally crucial steps for semiconductor manufacturing: deposition, photoresist coating, lithography, etch, ion implantation, and packaging. During the lithography stage, they use extreme ultraviolet light to print patterns that are, wait for it, thousands of times smaller than a single grain of sand. The precision is just mind-blowing, mapping out literally billions of transistors on a chip no bigger than your thumbnail. And what about the screen? The secret behind the legendary durability of something like Corning's Gorilla Glass is an ion exchange process. Basically, they cut the glass and dunk it into a 400 degrees Celsius bath of molten salt. The smaller sodium ions leave the glass, and larger potassium ions jam themselves right into the empty gaps. As it cools down, this creates this incredibly tightly compressed surface layer, which is exactly what gives you that crazy drop and scratch resistance.
Then, of course, there's the battery. Lithium-ion batteries generate power by bouncing lithium ions back and forth between cathode and anode layers. Now, during manufacturing, this electrode coating has to be perfectly uniform. It's constantly monitored by super advanced optical sensors. And this is absolutely critical, because if that coating is even slightly off, it creates a hotspot. Best case, it kills your battery life. Worst case, you get fatal thermal runaway, where the battery overheats and fails catastrophically.
All right, zooming back out, let's move to Phase 3, the assembly line.
Once the chips, the glass, and the batteries are perfectly dialed in, the whole process gets handed over to OEMs, or original equipment manufacturers, like Foxconn. These are highly specialized, massive-scale factories that assemble the devices for the major consumer brands. Inside these facilities, it's this incredibly choreographed dance of precision robotic arms and highly skilled human experts. They're guiding motherboards, screens, and cameras through over 50 distinct assembly stages. We're talking robotic soldering of microcomponents, applying hardcore adhesives for waterproofing, and carefully snapping in those incredibly delicate ribbons for the camera modules.
Geographically speaking, the landscape of where all this happens is actually shifting right now. Historically, China has been the undisputed leader here, but we're seeing a really rapid evolution in the global supply chain. For instance, India has emerged as the second largest smartphone manufacturer in the world. Thanks to policies like production-linked incentives, they built up a capacity of over 300 million units a year. Vietnam is also booming as a major hub, as brands actively look to diversify where they build.
But, as you know, all this gorgeous hardware is completely useless without a brain. That takes us to Phase 4, software and quality control.
Before a phone is ever approved for mass production, every single prototype has to survive a brutal dual gauntlet. On the hardware side, it is physical abuse, drop tests, bend tests, pressure testing, and super strict battery safety checks. But at the exact same time, the software goes through intense digital stress testing. Engineers are pushing the operating system to its absolute breaking point. They're checking system stability under heavy loads, seeing how the network holds up in dead zones, and fine-tuning camera performance. A phone is only deemed ready when it passes both of those gauntlets.
Once they clear quality control, we hit Phase 5, packaging and global distribution. The surviving devices get meticulously cleaned, sealed up in protective film, and boxed alongside their accessories, like chargers and manuals. And that kicks off the final logistical sprint. Millions of these boxed supercomputers are stacked in huge climate-controlled warehouses, then shipped out via cargo planes and massive shipping fleets to retailers and direct-to-consumers worldwide. Oh, and the relationship doesn't even stop at the sale. This phase actually kicks off years of ongoing after-sales software support and updates from the manufacturer.
Finally, we really need to step back and look at the broader picture in Phase 6, life cycle and environmental impact.
We have to seriously consider the planetary footprint left behind by this massive, endless cycle of manufacturing. And here is a genuinely surprising fact. If you look at the global warming potential of a smartphone over a standard 3-year lifespan, over 80% of its carbon footprint comes from its production phase, specifically the incredibly energy-intensive manufacturing of those integrated circuits and microchips. The actual daily charging and usage of your phone, plus shipping it to you, accounts for less than 20% of its total impact.
To put a real number on that, research estimates that the total annual CO2 equivalent emissions of using a smartphone, assuming average use, and crucially, including the energy drain on the mobile networks and data centers you connect to, is about 62 kilograms per year. To put that into perspective, 6 years of smartphone usage is roughly equivalent to the carbon emissions of a single round-trip flight from London to Barcelona.
Because the vast majority of that environmental toll is paid right up front during manufacturing, researchers point out a really simple, undeniable truth for us as consumers. The single most effective way you can shrink this massive industrial footprint is simply to delay upgrading. I mean, keeping your phone for 4 years instead of 2 fundamentally cuts your personal hardware footprint right in half. So, I want to leave you with this to consider. If your pocket is currently holding 80% of the periodic table, material shaped by millions of dollars of engineering, lasers, robotics, and massive global shipping, what are you truly throwing away when you casually decide it's time for an upgrade? Hopefully, this explainer gave you a newfound appreciation for that miraculous little slab of glass and metal you carry everywhere. Please like, share, and subscribe to the channel for more videos. Thanks for learning with us today.